right, so yeah, as I said, welcome to Aries Workshop number 2, Project Phobos Part 1. I'm Cass and with me is Anne. Today we're going to be introducing specifics about Project Phobos itself. So we're going to be introducing the different subsystems, and we're going to have a couple of guest speakers who are the team leads for Project Phobos. And next week is also going to be about rocketry. Next week's going to be more broad details on more broad information on rockets in general, rather than just this project in particular. So, Anne, would you like to take the mic?
Yep, sure. All right, so first of all, like a little bit of background about what this is all about. The Australian University Rocket Competition is a nationwide competition with the Australian Youth Aerospace Association, also known as AYAA. The whole thing about this competition is that people will come together in a team to try and build a high-powered solid fuel rocket, single stage, to either be able to reach a height of either 10,000 feet or 30,000 feet. Now, we started last year. 2020 was kind of the first time that we've participated in the team. Obviously, with everything that happened in 2020, we couldn't get into the workshop to really be able to build a rocket. And so that will be kind of like the main focus for this year with our team. 2021 competition, the information hasn't been like the detailed information hasn't been released yet by them, but from what we know, it will happen sometime this year in probably October, and the competition will take place in Queensland. Yep.
Awesome. So AURC has particular requirements of all the teams. This is some housekeeping stuff. So we have to design and build a single stage rocket, meaning it doesn't separate into multiple stages, each of them having their own separate engine. So there's only going to be one engine. We're going to have commercial off-the-shelf components, so we're not going to be trying to build our own engine because of safety reasons. We're going to carry a 2-kilogram CubeSat payload, which we'll speak about in more detail later in this workshop and also next week. And we have to aim for 10,000 feet. For this particular rocket, Project Phobos, we're aiming for 10,000 feet. We're hoping in the next year or so to introduce Project Deimos, which will be our 30,000 foot rocket, but that's for the future. That's only 10,000 feet happening this year. That's what Project Phobos is. And we have to be regularly sending information in real time about the location of the rocket. So it has to carry a beacon so that we don't have a rocket straying off into the middle of nowhere and then we can't keep track of it. That would be very dangerous because then we have a ballistic. So we're keeping track of it at all times. We also have to get certain qualifications to launch this rocket. So those qualifications relate to the motor size that we're using. And there's this thing called the EEE qualification, which dictates the size of motor you are qualified to launch with. And we have to start by successfully launching a small, what's called level 1 motor. And once we've successfully done that, as individuals, we will gain our license for L1, level 1, and then we can have a go at launching a level 2 rocket. So it's like a staircase, and we need a certain number of people with level 2 qualification in order to launch at all. So it's really important that we get some people involved with some launches on a smaller scale. It's going to be really fun and really exciting, and that'll get us our qualifications so that we can do the big launch in Queensland. We also have to have one member who has explosive license in Queensland. And the usual plagiarism, failing to meet deadlines, etc., all of that stuff applies as well. So we don't want to get disqualified. They won't be afraid to disqualify us. So we have to tread carefully. Anyway, that's the housekeeping for AURC competition. And I'll pass it on to Anne.
Yeah, awesome. Yeah, just a note about the AURC. They have a website, and if you go on the documents tab, it's all laid out with like more specifics of their rules, their standards, and things like that. So definitely on your spare time, go ahead and go on their website and check out some of the documents. Although it is a note that it's not updated yet. They haven't released their 2021 schedules or detailed requirements, but hopefully they'll come sometime soon. But it's good to kind of just see what they've got at the moment, because that kind of lays out what is expected anyway. Okay, cool. So some information about our project so far. As you can see, that version 0.6.3 is kind of like the latest version of our CAD model of our rocket. It's a fiberglass airframe. I think that we can go into further details from the structures team about that information later. Its length is 180 millimeters and its diameter is 146 millimeters. I think the top part is 150 maybe. I'm not too sure about
So
that.
I'll just interrupt you there. Sorry, Anne. I believe the version 0.6.3, can you see my cursor, by the way?
Yeah, we can see it.
Yep. So this version on the top left is an older version of the design with that transition
with the
with
fairing.
the wider nose cone. I believe it's been updated since then to the bottom right version.
Oh, I see.
So now we don't have a transition, just for simplicity.
Yeah. Okay.
So the whole thing is
the
same diameter.
Okay. Right. Okay. Cool. That's good to know. All right. And on it will be real-time telemetry and video, which will be more. There will be more information about that from the avionics team. We also have a CO2 parachute ejection system, which the internal team has kind of worked quite hard on. Because of the fact that we are trying to avoid using black powder to try and eject the parachute. We've also got the weather balloon for pre-launch conditions and a reaction wheel to help stabilize the rocket during flight. Some of the requirements, as we kind of mentioned before, we will have a CubeSat as a payload, and it will be a 1U CubeSat around 2 kilograms. This rocket must be fully recoverable, and that means that with the stages, it must be attached together as well, and there must be a tracking or a beacon, as mentioned.
Yep. So what is the payload for this rocket? It's a CubeSat, which is a small standardized form factor for satellites, for what we call microsatellites. And they're only 100 by 100 by 100 mil. There are a couple of other shapes and sizes which are sort of like a few of these cubes next to each other in size. The one that we're working with is called a 1U, which is just the size shown here in this image. And currently the idea for this payload is to track the positional data for the rocket. So we need to keep track of its altitude, its heading, velocity, acceleration, rotational acceleration, rotational velocity, etc. So it's going to include a GPS unit, which is actually going to provide the what's called the ground truth data, the most reliable data, so that we know exactly where the rocket is. And we're also going to be attempting to track the location of the rocket without GPS, which is significantly more challenging and requires a lot more creative thinking. And we'll get to that in more detail later on. But this payload will have a GPS system and a little antenna, which is pretty cute. So that's an intro to the payload. By the way, actually now would be a good time to mention that we have Grace here who can talk about the payload. She's the avionics and payload subsystem team lead. So Grace, would you like to introduce your subsystem and your team?
Yeah. Hey, can you hear me?
Yeah, we can hear you just fine.
can
Thanks,
hear you.
Grace.
Cool. You pretty much summed up payload pretty well. Yeah, given 2020's conditions, we didn't make any development. So yeah, there's not really too much to say other than our ideas, which yeah, it's a 2 kilogram 1U payload. I think our original idea was to implement a reaction wheel, as Anne mentioned, to stabilize the rocket in flight. That idea may or may not change this year, but I think that's our preliminary design ideas at this stage. In terms of the avionics, I think you guys have really summed up everything pretty well as well. So it's going to be all the onboard electronics and sensors, things like that. So we have altimeters, GPS, or real general model rocket sensors, I suppose. There's also a few challenges which the competition is including, which includes tracking of the rocket in a GPS denied environment. So how we would actually, well, the name's pretty pretty much explains what it is. So that we haven't actually tackled any of these challenges yet, but this year we absolutely will. I think we get our equipment on Friday. Around Friday. So that'll be really exciting to finally make some development. And there's a few other challenges as well, like the transmission of data at apogee, and how well the latency is and all that sort of stuff. But yeah, that's pretty much what the avionics team is. It's all the onboard electronics. We have a really great team this year, so really excited.
Yeah, awesome. And it sounds like you've done a fair bit of research on potential components and what sort of sub-components we might need. Like, for example, with the reaction wheel, what sub-components of the reaction wheel we might need, for example. So you have made some progress. Don't sell yourself short on that one.
Yeah, no, absolutely. Yeah, I mean, we have done pretty much as much research as we all can as a team, and we did try and simulate a few of these, designs online in Tinkercad and stuff. So playing a bit around with a few Arduino components. So yeah, we definitely did. It wasn't not productive. Yeah. So, but it will be definitely so much more exciting once we do have our equipment this year. So very keen for that.
Awesome. Look forward to seeing what you do this year, Grace, with your team. Appreciate it. I know you might have to leave early, so we thought we'd get you to present first.
Mm-hmm.
Thanks for coming. Appreciate it.
All right. No worries. Thanks.
So we've actually got a couple other team leads that we might get to introduce their subsystems as well. There are 4 subsystem teams in total. So first one, the aerodynamics lead, is Jack Lee. Jack, would you like to introduce a bit?
Yeah, sure. So hey everyone, hope you can hear me well. I'm Jack, and I'm the aerodynamics team lead. And similar to, I guess, Grace and all the other sub teams, last year was quite difficult being entirely online. And especially, when you're building a rocket, you need to be able to go out and test and learn physically. And so I think that was something we all struggled with. But yeah, we were able to do some, kind of preliminary CFD work. Still a lot to kind of learn and develop this year. So yeah, we've got a great team, a lot of new and excited, passionate people. So yeah, and then the goal for the aerodynamics team is to use computational fluid dynamics software, which is being provided to us by ANSYS and LEAP Australia. So thanks to those guys. And with that, we can essentially put the rocket shape through an airflow and see how it reacts. And so specifically, as the rocket gets higher and faster, it gets higher and higher into the transonic and supersonic regions. And so that adds compressibility effects of the air. And so, when you're studying turbulence just on your own with kind of basic flow, it gets pretty tricky, but adding the high speeds that the rockets go up to, it gets even more difficult. So yeah, hopefully we can sort all that out this year, and then as well help build the airframe, which we are doing in collaboration with the internal structures team this year, because it is our first time and there's a lot of unknowns, a lot of things that we're not sure of. So we thought it'd be best if we just get as many people as we can on it. So we're working together on that.
Beautiful. Will you be manufacturing that in the engineering workshop on campus?
Yeah. So, as we get more access on campus, we'll have access to the workshops, and we'll be able to all see each other face to face and be able to actually build our rocket physically and be able to touch it instead of just looking at it on a computer. So that'll be great.
Can't wait for that. That'll be a really satisfying thing after doing everything online last year. Yeah, it'd be nice to actually do something we can tangibly hold. Yeah, awesome. Thanks, Jack. Appreciate it.
Good. Thanks.
All right, so the next subsystem is internal structures. Unfortunately, Kian, the team lead, couldn't be here tonight, but Anne, would you like to talk? Well, we can both talk about this subsystem, considering we're both on Kian's team.
Yeah. And I think Joel is Joel here? Could also give an update on like the
absolutely. If he's here.
Parachute ejector system. Okay. So basically the internal structures is everything that is inside the rocket that needs holding. So we work with the bulkheads, the avionics bay to hold all of the avionics that Grace works on. It's also including the connectors for the fin and the nose cone. And also, I think Joel can kind of talk more about it, but like the method for how we will eject the parachute. So we need a way so that at a certain point, the tube of the rocket can split, and so the parachute can come out in a way where it's we're not using black powder, but it has to be quick and fast enough so that the parachute can come out and not be entangled in any way. So yeah, it's a lot of what we've done so far has been a lot of simulating, calculating, but not to an extent because we had the answers program quite late on during the semester, which meant that we didn't do much simulation work, and we'll hopefully be able to use answers more during the start of this year to be able to figure out the design of all of these components for the internal structures. Did you want to add anything else to it, Cass?
Yeah, I mean, I can discuss, I suppose, this next slide here. So what we've done so far is determine the internal layout of all of the structures. And sorry, just give me 1 second. Oh, Joel, would you like to mention anything? I can see you've unmuted yourself.
Yeah. No, just just with the ejection system, if we can get black powder, that'd be ideal. But in case that we can't get it to pull through, then yeah, the CO2 thing will work. It's just using a big spring to pierce a CO2 canister that you use to inflate your bike tire. So should be pretty good. I've done a prototype and I've drafted up some manufacturing drawings. So hopefully, if the mech workshop's not too busy, which they are because they checked, we'll get it made maybe sometime 17.
Awesome. Sounds great.
Sick.
Thanks, Joel. Appreciate it.
Good.
Yeah, so Joel's given a pretty good summary of the ejection system there. You can see it in the images in the center here. There's a little servo motor that is got a spring-loaded pin that will essentially pierce the film over a canister of high-pressure gas that will then shoot out and will have enough force to blow the airframe into two pieces, at which point the parachute comes out, and the two leads of the parachute keep the two halves of the airframe together. And we're going to have two parachutes, and we'll go into more detail on the next workshop on exactly how that works, but it's going to split twice. We're going to have one parachute that slows it down to about 30 meters per second descent, and then a second parachute that slows it right down. So that is the internal structures team. What have we got coming up? We got more FEA simulations, so finite element analysis. We're going to have workshops on that as well if you're not familiar with FEA. And we're going to be calculating all the loads on all of these internal components to see whether they'll fail, whether they'll hold up, and simulating that. And then get to manufacturing, like Joel was talking about. So there's a lot to do. And the next subsystem is simulations. So Harry, is Harry here? If Harry's not here, then Jack can give some info as well.
Yeah, I don't think Harry is here.
All right, then Jack, would you like to mention anything?
Yeah, I'll just chime in here as well, because I've been able to help Harry out and the simulations team last year and this year with a lot of the work that they've been doing. And so the simulations team is quite an important team, because all of our kind of predictions and in a way sort of testing is done with simulations. So the goal of the project or the competition is to get the rocket to exactly 10,000 feet. So as close to it as you can, it's not as high as you can. It's an accuracy competition. And so it's important for the simulations team to be able to predict how high the rocket is going. And that way we can either, adjust it by adding ballast or removing ballast so that it is more accurate. And so what simulations is also quite a technical team, I would say, because to be able to predict it, you would need a lot of kind of, knowledge about the physics behind, the rocket, like gravity, drag coefficient, wind, how wind can affect it, and just how the dynamics of a rocket can play out as it's flying through the air. And so it is mostly kind of a software / code based subsystem. So, again, we've got a lot of new people with good coding background. So hopefully that can also take off this year. And then, so with the graphs, you can see that's next to Harry's face there. Those different lines kind of show the predictions so far. So, some of those graphs would show the actual height of the rocket versus time. So that's the main green one of the bottom one. And then you can also see probably the yellow one there that's showing the velocity. So as it reaches its peak, you can see that the velocity has gone negative, which indicates that the rocket is falling. So it's stuff like that that we're working on in simulations. And yeah, later on in the semester, simulations is hoping to have a weather balloon. So the weather balloon is flown kind of on the day of the launch to get the actual atmospheric conditions, like atmospheric pressure, humidity, wind. And so that can further refine the accuracy of the simulation. And that's something that they're working on in collaboration with the avionics team, with Grace and her team.
That's something I'm really curious about, actually. I'd love to see how that turns out. I think that's a really tangible way of increasing the accuracy of our modeling. It's really cool.
Yeah, no, it definitely sounds interesting. And yeah, a lot of people are excited specifically for the weather balloon part. So definitely everyone's looking forward to it.
Yeah, cool. And I just noticed that Hassan mentioned he might have something to add. Hassan, would you like to add anything to that? Hassan's on the Sims team.
So Jack pretty much said everything. He also mentioned so you see the graph next to Harry's face. So that's actually a simulation that was made using the Open Rocket software. And also, Jack mentioned what the lines mean. So what we so the text tag that we have been using are simple Python and some advanced Python libraries. And yeah, so I guess that's all.
Yeah, thanks, Hassan. It's a good point that the actual software we're using is OpenRocket and Python. So in the bottom left here is a screenshot of the rocket model in OpenRocket, and then those graphs were made in OpenRocket, and we'll be building custom Python software, custom Python modules that will be incorporated into the OpenRocket simulations to improve their accuracy for our particular problem. So Sims has a lot of work ahead of them. There's a lot to do. So there's a really interesting sub-team. Thanks, Jack, and thanks, Hassan. I really look forward to seeing what you guys get up to as well. All right, so Anne, would you like to take the mic again?
Yeah, so as mentioned with the schedule for the competition, it hasn't been released. We don't have the dates in particular, but based off of what the schedule looked like last year, here are some of things that we would be expecting for the competition coming up. It isn't just building the rocket. There's actually a little bit of reporting and documenting involved in the whole thing, and it actually is a fair amount of points that we get from it. So from last year, we had to start off with like the documentations and then the first progress report, as well as the simulation on OpenRocket. The progress report was worth 100 points, which is quite a bit. And midway through the year, there was a second progress report that we would have to do as well to touch on the changes, the plan. So the first one would kind of set up our plans, and then the second one kind of updates on what we've done since then. We also had to do a modeling and simulation report that kind of outlines how the method for how we will simulate everything. So using FEA and CFD and the particular program that we would use to do that. There was also a payload report that kind of is more specific on the CubeSat itself, what its use is for, and more detail on what that payload will be about. And then the third progress report kind of comes later in the year, then goes towards the final report, and the big part is also the building and the scrutineering of the competition day itself, which is worth 500 points. So that's kind of what the schedule looked like or was planned for last year. It might change for this year, but it's just worth noting that it isn't just the competition. We have reports that we have to do throughout the year, and that is worth quite a decent amount of points. Yeah, so in terms of certification, we are encouraging the team members who want to participate in the competition to do their L1 certificate. And like Cass has mentioned, it's more on the basis of trying to understand the process and the safety of having a rocket launched. But and I think we fly up to a certain height, and then the L2 certification is required to be completed by team members, and encourage amongst all of you guys to also try and do it as well. This year, a lot of prototyping and manufacturing is going to be pushed forward, and we would like to have that happen as soon as possible, I guess. I'm not too sure what the plan is in terms of our access to workshops, but I don't know if maybe someone in the team can kind of give that more information.
I may
on
jump
that.
in here, Anne, to chat a little bit about the fun side of things. So, yeah, you were absolutely right that we're looking at upskilling people into building bigger rockets and flying them. So that's the L1s and the L2s. And that is going to be happening quite soon. We've already had like a handful of people from last year construct. For anyone who doesn't know, this is an L1 rocket. So yeah, about yay big. And two of our members have been able to go to a launch day so far, and we have another 6 sort of getting ready to go. The next launch is going to be on April the 10th. So that is a launch run by Tripoli, which is the statewide club for rocketry. So pretty much all university rocket teams join up with this enthusiast club, and they organize launches of rockets that size and bigger down at an airfield, which is out in Druin, which is, you know, a bit of a trek, but we've organized a couple of trips to go down there before, and we'll be doing that again this year. For workshop access, actually, there's one specific point I wanted to bring up, that Friday is a workshop training day. So if anyone is free Friday from 9 a.m. to 5 p.m., usually is a lot shorter than that, like 9 till 1-ish. But to access the workshop, you actually have to do a training day. And I'm pretty sure there was an email from Gary earlier today, which is the workshop manager, saying that they need a couple of extra people to join in. So if you register online, I might see if I can find a link for that to post after the meeting. But yeah, if you want to do stuff in the workshop, this Friday is a good time to get your training. Aside from that, launch on April the 10th. So if anyone's keen on seeing some rockets fly to between 500 meters and a kilometer, it's really good fun. And also, we'll be planning to have just a bit of a park launch, so stuff more this size. And that will be before the end of March. We'll be organizing that. And that'll be something we'll be working towards in some workshops as well. We'll have some people getting ready to 3D print some rockets out. And don't worry if you're not up to that level yet, we're just sort of taking things slow as well. So yeah, in summary, get your training done this Friday if you can, if you want to be in the workshops, and mark down some time to see some cool launches on your calendar. That's April the 10th, and to be confirmed before the end of March, club small scale launch.
I just wanted to double check with the workshop training. If you've done the workshop training for, say, one of your subjects beforehand, like DFM, design for manufacture, is that counted, or is this like a whole nother training?
I believe so. So yeah, if you've had access to the workshop previously, I think you need to do like the induction, which is like half an hour every year, where they just show you where the fire exits are, and that's it. For the actual like full day of training, where you have to like build a hammer and like, you know, do all this kind of stuff, you only have to do that once, as far as I'm aware.
Okay, awesome.
Yeah, for those of you who haven't done the tools training before, there's just an LMS module that you can join, and it's pretty easy. If you just Google Melbourne School of Engineering tools training, you can add this sort of module to your LMS, complete the online test, and then you can come along on Friday, build some stuff, and then you're pretty much good to use the workshop. For those of you who have done the training, you just have to do the induction, which is much quicker. All right. Thank you so much, Ben.
Nice.
That's good news. I really would like to come along to that. Appreciate it.
It'll be good.
Awesome. Just got a message in chat. I'll just check. Faculty of Engineering and Information Technology now. We've merged. We've changed name. We're not Melbourne School of Engineering anymore. All right. So let's talk capstone projects. For those of you who are studying masters, a lot of you might be keen on finding a capstone project with Aries, and good news, we have plenty of capstone projects that we've associated with this project, and also another project, the Unimelb rover team. So we're always looking for people to have a conversation about capstone projects with us. So at the moment, we've got 3 capstone projects which are related to Project Phobos, and they're actually going to be actively assisting us in the competition. The first one is really cool, developing and constructing a small hybrid rocket engine, and Jisoo's actually involved in that capstone. Did you want to say anything, Jisoo, or is it not? Is it too early days?
I think Jisoo's not here.
Oh, it's Jisoo. Okay, sorry. Jisoo's might have headed off. Jisoo's our president and she's involved in this capstone. So feel free to send her a message if you're curious about that one. Also, Joel Tapper is a member and he's part of that as well. So we're going to try and offer more capstone projects as well in the future. So please inquire within if you would like to know more. Okay, so the two other capstone projects, one of them is the aerodynamics capstone, which would be like Jack was describing before. So designing the airframe and performing computational fluid dynamics simulations. For those of you who aren't familiar with CFD, we'll explain more about that as well. It's essentially a finite element way of solving fluid dynamics problems numerically. And that will provide pressure and drag information, as Jack explained before. We're going to investigate surface smoothness, and we're going to be testing the actual physical airframe in the lab. So that's one capstone project. Anne, do you want to cover this one?
Yeah, so this was what Grace kind of briefed up on, but it's an investigation into the CubeSat or the payload itself. So trying to work on a GPS payload and kind of figure out how to have a GPS signal that is standardized with ground truth signal. This is all, if you're interested in this at all, that is a second CubeSat that we will be offering. Yeah, I don't really know much more about it. Is there anything you'd want to add?
Yeah, no worries. I don't know much about that one either. I think it's pretty much what Grace described earlier. Yeah, awesome. And what's up next? So that's pretty much all we have in terms of week 2 workshop slides. Now we've got a couple of options from here because we still do have, let's say 10, 15 minutes left. The first option is to do more meeting the team leads or people involved with the project. If we've already done that and we're already familiar with each other through previous events, then I would be happy to briefly touch on the first few slides for next week because we've got heaps of content for next week. And that's going to be a deep dive into rocketry and really the nuts and bolts behind how a rocket operates. So what do you reckon, Anne? Should we have a look at week 3 slides?
Yeah, I mean,
Just
if we've got
briefly?
the time, we can definitely brief over like the first few slides.
Yeah, sure. Just before we do that, do we have any questions that anyone's dying to ask? Now's the time. Everyone is here to answer them. Feel free to ask in the chat or unmute yourself. If we don't have any questions, then what I'm going to do is...
May I ask a question
Ben's got a
to
question.
everyone that's come along? Was anyone in the workshops last year? So anyone here who's had a bit of experience with Open Rocket, designing their own rockets, etc., from last year?
Yeah, I have some experience. I mean, this is something that we usually have been using in simulations.
Yeah, good stuff. So Hassan's had some Open Rocket experience.
Yeah, a little bit.
Very nice. Okay, question from Alex. Excellent. So getting up to this, L1 and L2. So I'll do Alex's question first. For L1 and L2, basically, we had a group of team members from last year, basically sort of the management team and some people who are really invested in the project, get started on the L1s and L2s. They needed to do that because we need those licenses in order to compete in the competition. So basically, the people that had really applied themselves last year got to go ahead with the L1 and L2. For this year, basically, we'll be working our way up. So the first step will be coming along to the workshops and learning about how to design a rocket. And then you'll work your way up to building a rocket about this size. You'll be able to come along to some of our launches. And then, yeah, basically we'll be working our way up throughout the year in order to get some people to L1 and L2 if that's something they're really interested in. Does that answer your question, Alex?
Yeah. What's the deal with motors for the April 10th?
Yeah, so April the 10th, sorry, is this from Joel?
Yeah. Hey, Ben.
What's up, dude? So April the 10th, that is something that we're currently discussing with Unimelb acquisitions. We're actually like probably set up in the system now, so we can sort of just like order stuff. We have our own like I think it's Themis account or something. So Harrison is the man in charge of that. It's sort of a little bit early days for motors, but it's definitely something we're looking at, and you know, might have some other tricks up our sleeve. I might talk to you a bit more about that if you're getting ready to fly on April the 10th.
All right, sweet as. Thanks, dude.
No worries. Cool. Alex's question is Alex is happy with that answer for his question as well. And question from Sam, for the rocket project, can undergrad students contribute? Absolutely. So we've recently just gone through a hiring spree for our sub teams. So I think we've taken on someone more involved with that process can probably answer that question. Roughly a dozen people into the project. And again, thanks, Jack. Yeah, so about 20 people we've recently taken on through applications and interviews. But also, like, if people, like, I mean, that's how I, you know, worked my way up to becoming engineering manager. So I'm helping coordinate all the different subsystems. Probably should have introduced myself at some point. Hey, hi, I'm Ben. I'm the engineering manager, and I help coordinate subsystems. Sorry. Anyway, so I started off by just coming along to workshops, and I was one of the first people to just go ahead, teach myself how to 3D print a small model rocket. And I don't know if I have something similar around. I can't seem to find my first ever model, but it was about like yay big, entirely 3D printed, and it did not fly very well. But I was one of the first people to apply myself and go ahead and learn that and do that. And I just did that at home, flew my own rocket, and sort of just got involved with the team. And that's how, yeah, I started out. So yeah, any other questions? Otherwise, over to you, Catherine.
That's the time. Sure. So we've got about 8 minutes left. So we'll go till 6:30. So we'll jump into next week's slides, which are all about rocket science. And we'll just do a few just to fill out the time because there's so much to get through next week. I figure it'd be good to get a head start on those. And then we'll all wish you farewell. So part 2, actual rocketry details. Week 2 revision, we don't need to do that because we just did that. This is the index, and we'll upload these slides to the Slack in good time, so you'll have plenty of time to look over this. This is a list of terms that we would recommend you're somewhat familiar with if you want to work on the project. I know it looks like a lot, but if you're on a specific sub team, you'll pick up this stuff and you'll work on only a few of them at once. You won't have to work on everything on this screen at once, but it's good to at least have an idea of what all of these terms are in order to work on the team and make a really valuable contribution to the team. So I won't go through it because we're going to go through them separately. And did you want to just quickly go over this one?
Yeah. I guess these are just the stages in a flight for a typical rocket. So obviously you've got ignition and liftoff and powered ascent. This is all when the motor is still working, and it goes into coasting or flight. And once it reaches or hopefully it reaches 10,000 feet, that's when it reaches apogee, and that's the point in which it would start falling. And at that point you'd have ejection and charge, and the parachute will come out during its descent, and it would hopefully land and be recovered. So that's just kind of like the simple stages of flight. And I guess the most important points are when the motor is working, or the rocket engine is working during the liftoff, and reaching the point of apogee, which is where it would have a sensor of some sort to kind of detect, and that's the point in which you'd have to prepare for the ejection for the parachute.
Beautiful. Would you like to introduce this one as well?
But yeah, they're not.
Sorry, was that a question? Who said that? Okay. Yeah, sure. So in terms of just basic rocketry, it's all about Newton, and it's all to do with reaction and action. So the motion of the rocket is equal to the expulsion of the gas at the bottom, and that's kind of like where the thrust and the reaction of the thrust, which gives the rocket flight. Yeah, I guess that's kind of really the whole basics of this slide.
Action and reaction. Perfect. Easy. All right, propulsion. So there's a couple of different forms of rocket engine. There's solid fuel and liquid fuel, and there's also a hybrid which uses both types of fuel. We're going to be using solid fuel for ours, but the way propulsion works in the actual motor itself, and for the purposes of this workshop series and for the purposes of this club, we're going to use motor and engine interchangeably. Strictly, we should be saying engine, but we'll say motor. The fuel is burned with the oxidizer, okay, so that allows you to actually combust the fuel. And then the gases will create a high pressure chamber here in the center, and then they'll be accelerated through this nozzle, which is a converging diverging nozzle. And that will, as Anne was saying, the thrust force is the reaction of the fluid moving out. So the exhaust moves out and the reaction to that is thrust. So that's the very basics on how a rocket propels itself through the sky. All right. And I think this would be a good place to end the workshop, because we've got a big anatomy of the rocket section that we can dive into next week. There's heaps of info here, and we'll look at that later. So thank you very much for coming. Really appreciate it. And yeah, as we said, next week we'll do more rocket science stuff. It's really nice to see all you people here, and I appreciate everyone's help from the team, and your contributions are really valuable. So thanks everyone once again, and we'll see you next week, same place, same time. It'll be the same Zoom link and everything. Thanks a lot, everyone. Bye.
Awesome. Thanks, guys.